Hello children, good morning to all of you. Welcome back in physics class and we are studying motion in one dimension. In previous class we have started graphical representation of linear motion and we have done distance time graph. Today we are going to see velocity time graph. Children, when we draw the velocity time graph, time will be represented on x-axis and velocity will be represented on y-axis. Since velocity is a vector quantity, positive velocity means the object is moving away from the initial point, and negative velocity means the object is returning towards the initial position. Understood? From the velocity time graph, we can obtain two things. First is the distance and displacement. Second is the acceleration. So first we will see how to find displacement from velocity time graph. Positive velocity on the y-axis, negative velocity downwards on the y-axis. X-axis denoting the time, time is in second, velocity is in meter per second. Okay, the object is starting from A point and reaching to the B point. In this case the velocity is increasing, then from B to C the velocity is decreasing. After that C to D, it is the negative velocity. It is the negative velocity. Then D to E, velocity is constant, and then it is reaching to G. Then at G again velocity is constant, reaching to H, and from H to I the velocity is decreasing. So this is the graph. From this graph we can find the distance and displacement. How? See here. Since displacement is equal to velocity into time, from the area of these graphs, we can find the distance and displacement. If we want to find distance, then all the areas of the graph will be added. All the areas will be added and we will get the distance. To find the displacement, we will add all the areas with their sign. How? See it. First, area of triangle ABC is equal to half into base into height. Here base is 4 second and height is also 4 meter per second. 4 second is the base and 4 meter per second is the height. By solving it, 4 to 8. 8 meter is the displacement and distance both. In the case of first one, triangle ABC, the distance and displacement both is 8 meter. Now, in the second one, this is the trapezium. So, area of CDEF is equal to half of sum of the parallel sides into distance between them. So, here 1, 2, 3, 4, 5 is the one parallel side and 3 is the second one, means half into plus 5 plus 3 into the distance between the parallel side is 4. It is minus 5 meter per second. See, understood? Half into sum of parallel sides into distance between them. By solving it, it is 4, 5, 20 meter. See, negative sign is showing the negative displacement, means the object is returning towards the initial position. Okay, now the third graph, area of FGHI, area of this graph, that is also a trapezium. So half into 1, 2, 3, 4, 5 and 3. This is also 5 and 3. Sum of the parallel sides into distance between them is 4. Here the velocity is 4 meter per second. By solving it, 16. See this one. Now if we want to find distance, then all the numbers will be added. See here, we will not take negative sign, because distance is the actual length of the path and it is never negative. So we will add all these and then we will get 44 meter. But if we want to find the displacement, See this one. To find the total displacement, the areas will be added with their sign. Understood? In the case of displacement, simply the numbers will be added. But in the case of displacement, numbers will be added with their sign. So it will come 4 meter. So displacement is only 4 meter. Understood? Distance is 44, but displacement is 4 meter. Okay? Now pause the video and note down these things. Okay children, we have seen how to find displacement. Now we will find how to find acceleration. Okay, so we will take the first case. In the first case, if the velocity is uniform means acceleration is 0. In this case, the acceleration will be 0. But what will be the displacement? See here. The x-axis will denote time. Suppose we are taking time in second. Y-axis will denote velocity. Suppose it is meter per second. Now 1 second, 2 second, 3, 4 and 5. This is 5, 10, 15, 20, 25 and 30 meter per second. Suppose the object is moving with velocity 20 meter per second. Since velocity is not changing, then after 1 second it will be same. After 2 seconds also it will be same. After 3 seconds also it will be same. That means if we plot the graph, we will find a straight line. We will find a line which is parallel to x-axis. This line will show the acceleration. This line will show the acceleration which is parallel to the x-axis, and that is why it is 0. Acceleration is 0. Now what will be the displacement? Suppose you want to find displacement after 3 seconds. After 3 seconds, see. This area, the area of the graph, area between graph and the x-axis, area between graph and x-axis will show the displacement. So it is 3 seconds into 20 meter per seconds. So 20 into 3, 60 meter. In this case, displacement is 60 meter. Understood? If the object is moving with uniform velocity, we will find a parallel line to the x-axis. In this case, acceleration will be 0 and displacement will be area covered between the graph and x-axis. Okay, now see the second case. If the object is moving with uniform acceleration, if the object is moving with uniform acceleration means equal rate of change of velocity is same. Rate of change of velocity is same. This is the meaning of uniform acceleration. In the same time of interval, same velocity is increasing. See, again time will be denoted on x-axis, velocity will be denoted on y-axis. 1 second, 2 seconds, 3 seconds, 4 seconds, 5, 6, 7, 8 seconds. This is 5 meter per second, 10 meter per second, 15, 20, 25, 30, 35 and 40. In 1 second, velocity is changing by 5 meter per second. Then in 2 seconds, it will be of 10 second, in 10 meter per second. In 3, it will be 15. That means if you draw the graph, you will find a line. See this one. This line will denote the acceleration. Understood? See this one. In 1 second 5, in 2 seconds 3. See, in 1 second 5 meter per second velocity is changing. In 2 seconds the velocity becomes 10. In 3 seconds velocity becomes 15. In 4 seconds the velocity becomes 20. Understood? Now suppose you want to find the slope of this one, because this line is denoting the acceleration and acceleration is equal to velocity upon time. That means slope of the line will give us the velocity. Understood? Slope of the line will give us the velocity. So how to find the slope and displacement we will see. First note down these things, then after I am going to remove this side. Okay, I am going to remove the case 1. So see here. Here the acceleration will be found. Acceleration will be equal to slope of. To find the acceleration, take any 2 points on it. Suppose this point is A, this point is B. That means slope of AB. And how to find the slope? See this one. Slope of AB will be equal to BC upon AC. What will be the value of BC? 25 minus 15. Value of BC is 25 minus 15. And what is the value of AC? 5 minus 3. 5 minus 3 means 10 by 2, which is equal to 5 meter per second square. Okay, now see how to find the displacement. Displacement in 4 seconds. Displacement in 4 seconds is equal to, in 4 seconds, the area covered by this graph, that will be called the displacement. Suppose this is P, this is Q and this is R. That means area of triangle PQR will be equal to displacement. Now area of triangle formula is half into base into height. Base is 4 seconds, height is PQ, which is equal to 20 meter per second. So by solving it, 2 dividing 4 coming to 20 into 2 is 40 meter. That means displacement in 4 seconds is 40 meter. Understood? Because the displacement is the area drawn, the area of the graph. Okay, now I am going to remove it. If the object is moving with uniform retardation. Uniform retardation means the velocity is decreasing. See here. This is the time in second. This is velocity in meter per second. 0, 1, 2, 3, 4, 10, 20, 30, 40 and 50. Retardation means the velocity is decreasing. In this case, Suppose the velocity is starting from 50 and after 4 seconds it becomes 0. The velocity is starting from 50 meter per second and due to retardation the velocity becomes 0 in 4 seconds. So this is the graph. Here this line will denote, suppose this is A and this is B, then this AB line will denote the acceleration. Okay. In this case, if we want to find retardation, then retardation will be negative of slope of AB. Okay. Retardation will be negative of slope of AB. This point you have to remember. When you are finding the acceleration, slope is positive. But if you are finding retardation, then slope should be negative. And how to find the slope of AB? Suppose this point is C. Then you will say that negative sine of CA upon BC. This is the method of finding the slope of negative slope of AB. Value of CA. CA is 0 minus 50. This is the negative sign. BC is 4 minus 0. So it will become, see, negative sign of minus 50 upon 4. Minus into minus becomes plus. 50 upon 4 means 12.5. 12.5 meter per second square is the retardation. Understood? Now, how to find the displacement? To find the displacement, we will find the area of this portion. Area of this triangle will be half into 4 into 50. Area of triangle is half into base into height. This is the method and it will come in meter. That means 100. That means in this graph the displacement is 100 meter and retardation is 12.5 meter per second square. Okay. Now pause the video and note down these things. Okay children, now we will see the third case. If the velocity of the body changes instantaneously, instantaneously means all of a sudden the velocity changes. Practically these things are not possible. All of a sudden the velocity does not change, but we will assume it. See here, in the first case, for the 2 seconds, the object is moving with 10 meter per second. For the next 3 seconds, the object is moving with 20 meters per second. Okay, and here this is the positive velocity, means the object is moving away from the starting point. Then after 5 seconds, for the next 4 seconds, the object is moving with 15 meter per second. And since this is the negative velocity, means the object is returning towards the initial position. So what will be the total displacement here? We know that to find the displacement, we find the area of the graph. So here, what will be the displacement? See here. Displacement is equal to area of this first part, area of the second part and area of the third part. Area of the first part will be 2 into 10. 2 second into 10 meter per second, because this 2 is the second, this 10 is the meter per second. Plus area of the second will be 3 seconds into 20 meter per second. 3 second into 20 meter per second plus area of the third one. See, there is the negative velocity, so this displacement will be negative. Okay, and 1, 2, 3, 4, 4 seconds into 15 meter per second. Understood? Area of all the three is added with their sign. So this is the downward of x-axis, means this is negative area, so it will be kept in negative sign. Now 25, 2 into 10, this is 20 meter. See, displacement is 20 meter plus 3 second into 20, 60 meter minus 4 into 15, 60 meter. So you can see that the total displacement is 20 meter. Understood? Here velocity time graph is over. Now we will see the acceleration time graph. So pause the video and note down these things.